Grounding systems. Is zero potential truly achievable? Imagine standing on a vast, open field where the Earth seems perfectly still and stable. Now think about how electrical engineers try to make that Earth the ultimate reference point for safety and system stability. That's what grounding systems aim for. They set a common point called zero potential, which is supposed to be at 0 volts. This helps protect people, equipment, and ensure everything runs smoothly. But in real life, can we ever truly reach that perfect zero? Let's find out. In theory, zero potential means the Earth has a constant electrical potential of 0 volts. Engineers use it as a baseline to measure all other voltages in the system. This makes designing and analyzing power systems easier. When a fault happens, grounding helps direct fault currents safely back to the source, triggering protective devices to turn off power quickly. This keeps equipment safe and prevents accidents. Different grounding methods influence how close we get to zero potential. Solid grounding connects the system directly to Earth, allowing large fault currents to flow. Resistance grounding adds a resistor to limit fault current, making system operation safer. Resonant grounding uses special tuned coils to cancel out fault currents, reducing stress on equipment and improving reliability. Each method has its advantages, but none can make the Earth a perfect 0 volts. The Earth itself is not a perfect conductor. So conductivity varies with moisture, temperature, and composition. During fault conditions, current flows through the Earth, creating tiny voltage differences around grounding points. These differences mean the Earth's potential can shift slightly, especially during high currents. Also, at higher frequencies, the Earth's behavior becomes more complex because of inductive and capacitive effects. This makes the idea of a single, stable zero potential impossible to achieve perfectly. Grounding systems are designed to keep these potential differences as small as possible. The goal is to make the Earth's potential close enough to 0 volts to protect equipment and people. It's about managing and minimizing voltage gradients and ensuring safety rather than reaching an absolute zero. This way, systems stay stable, noise is reduced, and faults are cleared efficiently. So, in the end, the answer is that true zero potential is more of an ideal than a reality. The Earth's physical properties and electrical behavior prevent us from ever reaching that perfect point. But with proper grounding techniques, we can get close enough to make power systems safe, reliable, and effective. That's why grounding remains a vital part of electrical engineering, balancing practical limitations with the need for safety and stability.